In this video, we're going to use Elem Tools as a tool for us to analyze the daylighting in a Revit model. In this case, the Revit model is a very simple two-room schoolhouse with one room on this side with south-facing glass and another room on this side with north-facing glass. And here is the ground floor plan. So before we get too far into it, I just wanted to review. Elem Tools, when installed on a computer or on your computer, is just a plugin in Revit that shows up right on the tabs above your ribbon. And when you use it for the first time, you typically have to initialize a project. In my case, I'm using a trial version. That's what that pop-up was that you saw. But if you're in the computer lab, you're going to have a activate license button around here. And what that is since the school has a network licenses, every time you use it, you just activate the network license. It'll give you a license and it'll be fully functioning. But you can see, just as if it was a part of Revit, you flip to the Elem Tool tab and you have a lot more controls over your lighting in your space. So before we start using any of this, one thing you have to make sure you have your building in the correct location and the correct orientation. So the way you do that is you go to Manage, and with your project location part of your ribbon, you click on the location. And you can type in an exact address here, or you can do it visually by moving it around. In this case, we're located right on City Hall in Philadelphia. And now, that's fine. We're going to keep that location for this project. But one thing to recognize is that Philadelphia is at about a 7-degree angle from true north. And that's one thing that's not reflected in this model. So while the location is okay at City Hall, we want to make sure that our building is also oriented correctly. And to do that, what you do is when you're in your floor plan view, you scroll down until you get to orientation over here. Currently, your orientation is Project North. Project North, what that means is it's your north on all of your sheets or all your pages that you're printing. So if you have a way that your floor plan fits better on a page, your Project North is normally a direction that makes it so that you're orthogonal to the bottom of your printed sheet. So with that, in order to actually change your rotation of a project, you have to make sure your plan is set to true north. Apply. And you can see nothing changes because in this Revit model's mind, true north is straight up, and this building is facing true north. So what we'll need to do is we'll click on the position here, and we're going to rotate true north. And you see right away you have a rotation command. Now you might think to rotate your entire model. Don't ever do that. Just leave your model as it is, and it seems counterintuitive because what you're actually doing is rotating the rest of the universe from your little model, but it's better that way. It's better to draw your model orthogonally and rotate everyone else to you. So what I'm going to do is, you'll see it kind of snaps when you get to 90 degrees. Click once, and we're going to turn us about, I believe it's 7 degrees. Type 7, hit enter. Now we are oriented more to the Philadelphia grid. And what you'll see is when I switch it back to Project North, it comes back to being orthogonal. So you're still drawing it orthogonally, which makes it easier. But when it actually runs the sun or any kind of solar angles, it is correct to what true north should be. So let's run some analysis on this space. So with that, we go to Elem Tools, and first thing we want to do is pick some points that will actually give us meter readings, and it starts off by default on a 2-foot grid. And if we click down on this, you'll see you can pick a planar face, a room work plane, or a space work plane. Really, when you're using architectural Revit, you won't know what a space is. That's more of an MEP item. So we're going to look at room work plane and a planar face, and we're going to use both of them. So for room work plane, if you click it, since there's already rooms placed inside this Revit model, you see it wants to snap to them. So let's do the south room first. You see it gives you a preview of your room, and you want to make sure that your work plane is at 2.5 feet off the floor, or 30 inches. So we're on a 2 foot by 2 foot grid, 30 inches off the floor. That's kind of work level height, and we're making sure we understand what our lighting is at that height. So we can hit OK. We're going to add the same points to the north room. Again, make sure that that is at 2.5 feet. If it's not, just type it in. And if you wanted a different arrangement of your spaces for your grid, you can choose something that's not 2 foot by 2 foot. And hit OK. Alright, and one other thing I'm going to do is I'm going to add some planar faces on these side walls so we can see how the light runs along the side walls. And I'm just going to do these two. So the first thing you have to do is be able to see those, and you can't really see them to click on them in plan. So I'm actually going to do this in a 3D view. And once you're in the 3D view, you can zoom out a little bit. Scroll down over here until you get to the section box command and click it. And you'll see a little box shows up around your model. If you click on this, you're going to notice these little blue poles that show up and allow you to move the box. We're going to use this. This is a very handy tool for cutting things and editing them in 3D. And we're going to cut the side of the building off. Don't worry, it's still there. This is just a view. You didn't actually chop part of your building off. And now we're going to add points, and we're going to do it to a planar face. And you'll see it places a little family on there. And yes, it does actually say calculation points on it. And yes, be careful when you place these things, because if you then print out a section of your building for your final presentation, you might find that that's still showing up. So once you're done with your analysis, I would recommend either hiding or deleting these calculation points. So that's how you place one. And then I'm going to cut it a little further in. And I'm going to do this wall in here. And you'll see right when you click this, I kind of snap through this very quickly. But it's very similar. It has the same spacing, and 2 foot by 2 foot spacing. And in this case, we're not offsetting off the wall. We want to keep it at 0 feet, so it's placed right on the wall. Hit OK. That little family shows up again, and you click on the face that you want it on. Alright, so we have 2 planar faces and 2 rooms marked with analysis points. Now, you'll still see the color mappings when you run your test, but the analysis points just give you a little bit more data. So with that, now we can start to do our analysis. Let's go to ground floor. And there's a couple different ways to run your analysis. First of all, since we are we're going for daylighting, we don't want it set on general use. We want to click this, and we want to make it go to daylighting. What these are is general use is your electrical lighting. Emergency is if you actually have a very complex electrical plan and you have some of your lights set as emergency fixtures. Emergency knows that, and when it does its study, it'll tell you how much light your emergency fixtures alone put out throughout your building. So that way you can test and make sure you have the right illumination for somebody exiting the building if it's in an emergency state. And then third is daylighting, which is self-explanatory. When you click on daylighting, you get the daylighting parameters button. If you click on that, it will reflect the latitude and longitude location of your project that's used in Revit, and it will reflect the degrees of true north. So if you know your true north is not 90 degrees and you come in here and you see 90, that means you probably want to make an adjustment. And you can even do it in here. You don't have to do it through Revit. Right now it is doing the winter solstice at noon. And what I'm going to do is just change this slightly to do the winter solstice at 2. So it's 2 p.m. It does a 24-hour clock here. And hit OK. And now we're ready to go. So what we're going to do is we're going to do two rooms at the same time. And your options for calculating are a single room, multiple rooms, and then one that's hidden in here is calculated selected elements. Calculated selected elements will calculate anything you currently have selected in Revit, but it will not do any room work plane analysis. And you'll see what I mean when we get there. So let's do multiple rooms. Click on one, click on another, and then we come up here to the option bar and click Finish. What this is doing is it's asking us if we want to run analysis on one room at a time, even though it's doing both at the same time, but without these rooms sharing any light between each other. With the way this model is made, these rooms really don't share any light amongst each other, but for now we're going to hit Combine in case you do have a clerestory or something on that inner hallway of your actual design. That would allow, if you run it as combined, it will allow it to analyze both rooms sharing light coming in. Blow this up a bit. So over here you'll see it's running its analysis, and here it's giving you a visual update of what's happening. So it's bouncing light around in the spaces. You can see it's coming in through the north now. You clearly have a lot of light coming in through the south. Now it's calculating the points down here. That's all the calculation points we added to the floors and walls. So it's done with its original analysis, and it's just coming up with the data for those points. And calculation is complete. So you can see all of the points are mapped on the walls, and they're currently mapping in its illuminance. So what we want to do for more common analysis is look at its pseudocolor or false color mappings, and we're going to review its illuminance. And when we do that, we're going to click down here on this arrow, and we're going to switch it to foot candles. Click on illuminance. So now you can see your data points change to foot candles on both the planar surface that we added that piece to and your work plane surface. And you can move around a little bit by holding your, if you just hold down your left, let your left mouse button, it'll do a 3D orbit. And you can see that these data points are up off of the floor because they're at the work plane level. And these data points are on the wall. And you can see when the sun comes in, we get very hot right in here, obviously. We're at 1800 foot candles right there. And then as we get away from the window, we go all the way down to about 19 to 20. And if you go down far enough, you'll even see what's happening on your ceiling. You can see how the light's bouncing as it comes in through these windows. So this space is getting a lot of glare right in the front of the room. So that tells you something. That tells you something about the winter solstice and what kind of light is coming in the early afternoon. So once you have that, you can look at the data in many different ways. You can save it, and this would save it as a JPEG. And to do that, you can also flip to plan views, you can flip to elevation views, and more axon views. These are good presets so that when you do several of these studies with different options, you can stick to some of these presets and you're saving your views from the same exact angle each time. You can compare the data from one to the other. But that's really it. That's as simple as it gets for studying your daylighting. So we'll do one more test. I'll make an adjustment and do one more quick test so we can see how it comes out. So if I go to my 3D view over here, you can see as soon as we change the model, it's going to say the Elem Tools calculation results are no longer valid. That's okay, we'll reset the results. The roof monitor's not working very well. But what these are just simple little models that I put in to just test by adding skylights or roof monitors, see how they would actually function in the space. So we can always add some skylights in and then very quickly run another test, see how that changes the lighting in the space. Go back to the ground floor. We don't need to add any more points because they're already in there. We'll do multiple rooms. We'll hit finish and combine. And it's going to do the same analysis. You should see the same process. The skylights likely won't change the interior too much with this low of a sun angle, but if we changed our daylighting parameters to a more summer date, summer solstice, or an equinox, you would see that some sun will come in through those skylights and light the space. It's almost done with its calculation points, and then it'll show us the results. Once again, it snaps back to illuminance, so we're going to switch it to show the pseudo color illuminance, and we are going to change it to foot candles. So not a big change with the skylights, but you can start to put in light shelves on the inside or overhangs on the outside to adjust the way the light comes into these spaces. One last thing before we end this is one nice way to see this is by going back to your Revit floor plan. As the Elem Tools rendering viewer is sometimes a bear to work with and to show your data clearly, you can go to any floor plan and click View Results, and it'll show you all of your data points. Here, since my plan is at 1/8 inches and equal to a foot, they're very tight together, so we would need to make it a larger scale so that the data points are more spread out. You also see if I zoom out, I have a legend. And I can move up next to this and always print out. You also see that, again, it's doing illuminance. That's its default. To change that, you click on the points themselves, and we're going to go to Results Visibility, Edit, and change the units to foot candles. And that gives you the luminance in foot candles. So you can play around with the settings a little bit. Of course, you want current data, the most recent solution that was run. And you always want to check the analysis display style too. mostly because sometimes, especially with Ecotect, it doesn't have red as the maximum value, which really throws off the way people look at things. They tend to look at things as blue to red, but you'll find that Ecotect will sometimes have yellow at the top, and your first knee-jerk analysis will most likely not be correct. And then this shows how to set up your legend and what kind of settings you have. And that's it. That's how to do a very simple daylighting study within Revit using the Elem Tools plugin.